Hey folks, Mr. Dell here. Hey, we were looking at finding the area of a shaded region that is made up of a regular hexagon and a circle. So I'll show you the process here. This is coming from CPM. This problem is from CPM Integrated Math 2, and this is section 9.1.4, number 9-46. So if you notice my image, the shaded area is what's being inscribed by the circle and a regular hexagon. So you have the circle on the inside, right? So you'll have to find the area of that circle. And then what we'll do is we'll also find the area of the hexagon, and then we have to subtract them. So really our process here is going to be the area of the hexagon minus the area of the circle, right? And then because it's taking away the all of this circle here. If you take away that circle and pull that out, then what's left is if just the area of these little regions in between the circle and the hexagon. Okay, so let's go through that process. So first of all, how do you find the area of a hexagon? So remember, area of a hexagon, if I were to draw what I have here, area of a hexagon is made up of six, because it's six sides, six exact circles. Or excuse me, circles. Those are triangles, I just drew. Six equilateral triangles here, right? Because that side is six. And what you have is you have six triangles, and this whole thing is made up of 360 degrees. So each of these are 60 degrees. And these are also equal, so those are also equal to 60 degrees. So you have all these equilateral triangles with a side length of 6. So if I can find the area of one of those triangles, then I multiply that by 6. So if one side length is 6, right? If this bottom part is 6, 6.0, or just 6, then if I drew the right triangle here, that the height, I would know that'd be 3. And we know this is 60. So I have a 30, 60, 90 triangle. And if the side opposite of the 30 degree is 3, then the side opposite of the 60 degree is 3 root 3. 3 square root of 3. So area of this triangle is 1/2, or base times height. So the base is 3 times 3 root 3. That's the height, all divided by 2. Right? So area is base times height. So not the base is not 3. Come to think of it, the base is 6, because the base would be the entire base of the triangle, which is actually 6, right? From there to there, 6. So it's 6 times 3 root 3. That's the height. So this gives me 9 square root 3. You multiply the 3 times the 3 and you get 18. Divided by 2 is 9, and you still have that square root of 3 there. So that's the area of just one triangle. So the area of the hexagon would be 6 of those. So 6 times 9 root 3, which is 54 square root 3. So that's the area of the hexagon. Now, minus the area of the circle. Well, I drew in here these radii, right? But that's the radius of the hexagon. So really the radius of the circle would be from there to here, which is really, if you look at that, it's also the height, the same, this length here, which is the radius of the circle, is also this length here as far as the height of the triangle. So that is 3 root 3, as we discovered earlier. So to find the area of a circle, remember, area of a circle is pi times the radius squared. So I'm going to take and multiply pi times the radius, which is 3 root 3, and square that. Okay, so if I look at this, when we square 3 root 3, it's multiplying, and I'll just do that up here, 3 root 3 times 3 root 3, and you multiply the 3's and you get 9. You multiply the roots, you get square root of 9. And 3 times the square root of 9 is the same thing as 9 times 3, which is 27. So this whole thing becomes 27 pi. So the exact answer would be that right there. If I didn't, now I would need a calculator to actually come up with the approximate answer, right? So I would take 54 times the square root of 3. And then I'd subtract that times 27 pi, which should give me, let me redo that here, make sure I did it right. So 54 times the square root of 3 should equal approximately 93.53, we'll say. And then 27 times pi is 84.82. So if I subtract those, I get approximately, so my final answer is approximately 8.71, and it's inches, so inches squared. So there's the area of that shaded region in two ways, exact or approximate. Okay, there we go.